introduction to what a GIS is. Next, please. Okay, so I'm going to be brief on this. Basically, it's a technology which brings in spatial and non-spatial data. Most of you have used Google Earth or Google Maps. Google Maps is a good interface to you. It is not a full-fledged GIS, okay, but it has many capabilities of a basic GIS. Now, basically what a GIS is, I can take the spatial information, integrate it with non-spatial information. Typically non-spatial, next please. Typically non-spatial information is represented in a database. Most of you use CAD, right? AutoCAD. AutoCAD is spatial or non-spatial? Almost fully spatial. Okay, a database is non-spatial. So for a guy like me who was in the construction sector, I used to use CAD and I used to integrate CAD with a database, and it gave me some GIS capabilities. This was in the mid-80s. But what we've happened is now a lot of GIS development has come from computer cartography, computer-aided mapping. Survey of India, for example, has a lot of maps. Today, if you want to buy a Survey of India map, it's available digital form with a GIS layer. I can get contours on one layer, roads on a layer, transmission lines on a layer. It's layered. You can still get a printed Survey of India map, but the printed map has absolutely much less value. India has always been very strong in remote sensing. Okay, so we need to, so GIS has now been an integration of all these technologies or all these areas, and you will find that I actually started using GIS between CAD and database, but in a lot of places in our country, the remote sensing people are the GIS people. Okay, or the Survey of India guys are the GIS guys. So, next. So, all a GIS does, just to give you a very brief thing, so I can have a map like we talked about. So, your Google Earth or your Google Map. I have my text data attached to a point data. So, a lat long or a georeference piece of information has immediately also got a tabular piece of information which has the data. Next please. Okay, so in addition to the basic representation, I can do querying, analysis, network, a lot of these features which can be used with a GIS. I'll show you some of them next. So for example, you do this in Google all the time. Show me where all these restaurants are, show me the route, all of that is what we basically call integration. And next. Okay. This is going a little more into the data structure. So those of you who are from the computer science or IT side here, how do I represent spatial data in a computer? What is the kind of data structure I use? Okay, as a civil engineer, I might use the application. But what is the kind of data structure which the computer will use to represent spatial data? How will you represent a map? Okay, so it gets quite, so I have two options. One is my raster or pixel based, which is a bitmap, which is not too much of a problem. All of you can relate to a bitmap. I can easily store a bitmap, but I don't want raster data. I might want vector data. So what is the difference between raster and vector? Yeah, in a vector, this line is, what do you call, the geometry of this line is stored. The computer knows that this is a line. In a raster, the geometry of the line is not stored, it's just a bunch of XY points which are pixels. Okay, so that level of data representation, today if you're using the package, you don't have to go to it, but in the earlier years, you had to understand how the data was stored. So in our application, we have, when we design the database and design what kind of layering we want to use, we have to decide what is the best way to represent the data. So these are some of the hidden details which we will not show in the application. And then what a GIS does is you have layering of information. You have to decide. So Nagesh will show you the various layers which he has to deal with. Next please. We do this. You can do spatial querying. If I'm on Google Map here, I can find out what are the bus stop near here, what is the bus route, and it is spatial querying. It is not giving me with not respect to the map, it is a spatial query. Next please. So these are things which you don't do in Google Maps. I can do buffering analysis. I can say, here is a lake, show me all the farm areas which are within 50 meters of this lake. Show me all the farm areas which intersect this stream and this lake. These are spatial queries. These are spatial logical queries. Okay, these are things that can be done. Next. Okay, I can then do overlay analysis. I can take a spatial query. I can do spatial proximity analysis through overlays. Again, you know, fairly robust today. Next please. I can do this again. Your Google Earth shows you a bit, but the accuracy is not enough. I can do surface modeling. I can do river water runoff. I can take this campus and say, if it rains, where does the water run off? Based on that, I can say, where should I put my check dams? All this is possible through a GIS. Next, please. I'm not going to spend too much time. The application areas are just huge. Next. Okay, so when you come to a GIS, as in any computing computing platform, you are dealing with people, software, data, procedures, and hardware. A lot of times, in my experience, people say that, oh, if I'm going to buy the software, buy the hardware, and my platform is on. Okay, so I'm sorry, I'll have to stop here. There's too much of noise coming from the back. Okay, so if I get distracted too much, I'll have to stop. Okay, so if you guys in the back, like I said, if you can't see this, I can understand, but you can go to sleep, but please don't talk. Okay, that will make it more difficult for me to concentrate and present. Okay, so when we take a GIS, we have a lot of times, so if you take any state department today requires GIS analyst. The Corporation of Chennai, the CMDA, the PWD, Metro Water, the roads, all of them require GIS analysts because we are all dealing with spatial data. You go to the rural side, anything you do, whether it's irrigation, whether it's crop management, in fact, many of our collectors today are trained to use GIS packages and to be able to ask for reports from GIS because it is becoming an integral part of how we manage our country. Okay, and a lot of times this is the problem with where we have faced issues is, and we have gone through several iterations of this. The government will give the department money to buy money to allot for GIS. Money gets spent on software. Money gets spent on hardware. Money doesn't get spent on training people. Money doesn't get spent on acquiring data. Money doesn't get spent on establishing procedures to use the GIS properly. In 2 years, what happens? Software gets outdated, hardware gets outdated, and there is really no benefit. So I think GIS is not a new technology anymore. One thing which, if you can really get good skills in GIS and how to use it, it's a need which the country has to do. Yeah, next please. Okay, so back one, Nagesh. So one of the challenges we are facing in our application, so one thing we decided is we don't want to pay for software because this is going to be an application which is more for the rural base. We should be able to implement it in a rural setting. We don't want to pay for software. We wanted to be able to work on as minimal a hardware as possible. And if we went in for commercial software, the problem was it costs lakhs and lakhs and lakhs of rupees. So fortunately, this was one of the evolutions that happened since 2005. Since about 2008, we found that there was good open source software which was available. And you can all download it today. It's called Quantum GIS, QGIS. Okay, it is robust, it is good, it gives you almost all the features which a professional package might give you, but it's a little more difficult to use. Okay, so if the civil engineering department here, you want to use a GIS or the computer science, download Quantum GIS and use it. It's there, the manuals are there, the support groups are there, there's so much you can do with it. Okay, and it does not require exorbitantly sophisticated hardware to use it. You will see some of the phones we are using are not, I think most of you will have much better phones. Okay? Next, so in addition to the back one more, in addition to this software, one of the things we didn't have is data. I need the map. How do I get the map? How do I show the farmer which his land is? How do I show him where the drainage channels are? How do I do that? I could go to remote sensing to develop the map, but but the resolution of remote sensing, what we started with, was not good enough. We needed high resolution images, which NRSA doesn't part with that easily. And if I want high resolution images, again, I need it for a village which they are not going to be flying over that easily. And this is the technology when it might be even 5-6 years back. Things have changed a lot today. Okay, things have changed. I can go and buy, I can't get high resolution imagery from NRSA of any specific areas in India, but I can go to a Russian satellite and get high resolution image of Tambaram Air Force Base, for example. And this is the way. I can't get it in India, but I can get it outside India. Okay, so that's the way the whole thing works. Yeah, next please. So when we actually do a GIS development, the inventory, building the data inventory is the tough part, is the initial part. You don't have much fun doing this because you're just populating the database. Only after that you can actually do analysis and management. So frankly, as an academic, I would say, look, this is not where I want to focus. I want to focus on analysis and management. So a lot of times I would use hypothetical data and then develop algorithms over it to be able to do fancy analysis, fancy management, all illustrative, hypothetical situations. But when we dealt with the project which Nagesh, or problem which Nagesh had, there was no point in doing a demonstration. It had to be an implementation. Next, please. Okay, so we come back to, now I think Nagesh, you're taking over, right? We come back to how we went about implementing this on the platform. I think one more slide, Nagesh, one more. Next slide. Yeah. So this was our basic architecture. Okay, we had a quantum GIS, like I said, open source with a GeoServer environment. How did we get the data? We used a mobile platform. Okay, today a mobile has everything from your GPS, all kinds of sensors on it. We used a mobile platform to collect the data, and we also had your GIS viewers to be able to do this. So Nagesh will get into the details of explaining the integration of this. Okay, Nagesh, over to you.